of u, the function that gives the rate of change of g of u at any point when the g of u is differentiable. How do we start to find g prime of u? What do we have to write? Can anyone get us started for g prime of u? Anyone? What do I have to write? What is the first step? What is the first thing I have to write?
Limit as h approaches 0.
Excellent. From, right? U plus age plus 1 over 4 u plus age minus 1 minus u plus 1 over 4 u minus 1 over h. G of u plus h minus g of u over h. What is our next step? Don't forget the limit operator, please. We have not applied it yet. Can anyone give us the least common denominator in the numerator? Anyone? The least common denominator here.
For u plus h minus 1 times 4u minus 1.
Thank you very much indeed. So this one is this, so it needs 4u plus 1. I meant minus 1, of course. What will I do without my whiteout? Okay, and here I have the other one, 4u plus h minus 1. Now watch me run out of room, I always do. 4u times u, 4u squared. 4u times h, 4u, 4u times 1, 4u. Negative 1 times u, negative u. Negative 1 times h, negative h. Negative 1 times 1, negative 1. And now, of course, I'm going to go up here to the moon and the sun. Okay, negative u times 4u. Negative u times h. Negative u times negative 1. Sorry about that. I have to put the rest at the top. Negative u times 1. Negative 4u times 1. Negative 4u. Negative 1 times h. Negative h. I hope you don't have to do that. So this is right here. So plus u.
I have a question.
Yes. Please, any
When
question?
you read the negative 4u squared, the negative 4u h, I thought you multiplied negative u at the end. I thought you multiplied negative u by h.
Am I looking here?
Yeah.
So negative u times 4u. Negative u. Oh, I wrote 4.
Yeah.
Thank you so much. I'm not hungry. I'm not tired. I just talk too much. Okay, thank you so much. So negative 4u squared minus uh and plus, I don't know why I wrote 4. Thank you so much. So now negative 4u, I have to check everything. Once I make an error, I have to check everything. Okay, I think I'm okay now. Remember, all terms without age must go away. Let's see. Some terms with age may go away. That's very possible. Okay, I found it. That's what it was. So this is 4u because what happened, I'm going to start again. What happened was I didn't write it, I jumped and I rushed. So I have to write g of u plus h. So u plus h plus 1 over 4u plus 4h and minus 1. I have to write this first so there is no ambiguity, because what happened here, I forgot the 4. So the whole thing makes no sense. So I have to put it in the recycling bin. Okay, so g prime of u equals the limit as h approaches 0, and I have to write it. G of u plus h minus g of u divided by h. So there is no mistake. I'm running out of time, so no excuse. Okay, so I'm checking now again. Everything is okay. Yes. So we have u plus 1 over 4u plus 4h minus 1 minus u plus 1 over 4u minus 1. Perfect. Now you already told me what it is, so this
Should be
means
u plus h plus 1 in the first one. In the first fraction of the
yes, of
numerator.
course. Where am I looking? As I said, don't trust me today. Again, so I have 4u. So keep an eye on what I'm writing. Thank you. No, I'm not trying to make mistakes to make sure whether you are paying attention or not. No, no, that's never going to be the case. I'm not trying anything funny. Okay, so it was, I copied. Yes, I did. Okay, so again, you already gave me the denominator, so I'm going to write it as 4u minus 1, 4u plus 4h minus 1. Okay, so 4u squared plus 4uh plus 4u minus h minus 1. Okay, then minus 4u squared minus 4uh and plus u. And then minus 4u minus 4h and plus 1. Very difficult to see, my apologies. I can't fit this in one row for the life of me. So but now I'm checking again. 4u squared plus 4uh plus 4u, correct. Minus u minus h minus 1, correct. Minus 4u squared minus 4uh and plus u. Minus plus, correct. So now minus and plus, that's correct. Okay. So now, all terms without h must go away, and some terms may go away. In addition to that, that's fine too. 4u with negative 4u, positive 1 with negative 1, positive u with negative u. Finally, I have negative h and negative 4h. Nice. So limit as h approaches 0. Again, there is nothing else, a negative h. Yes, negative 5h over 4u minus 1, 4u plus 4h minus 1, and I flip the denominator. This is the second step that always has to happen. And now I can apply the limit. Now the limit operator will be gone. What is the final answer, which will be the derivative function of the given function that gives the rate of change at any point where the original function is differentiable. Can anyone give us the answer? You will say negative 5 at the top for sure, but what would we say in the denominator?
Or u minus 1 squared.
That's it. 4u minus 1, everything squared because this is 0. 4u minus 1 and 4u minus 1. And that's 4u minus 1 squared. And this is the derivative of u plus 1 over 4u minus 1. That gives the rate of change at any point. Final thing. I promise this is the last concept in this chapter, last one. Okay, here it is. So f prime of x has only one definition. Again, I'm going to copy it here. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is one definition, just one. We do have, however, two definitions for f prime of a number. A is a number. It's not the same a from the limit that we played with. No, it's just any number. So there are two definitions. Two definitions. Question, do I have to use these? No. Do I have to use one or the other? No. You can always use this. And then just plug in the number. So if we're asked to find, for example, f prime of 2, we have two options. Okay, so let me just give you those two options. You don't have to use them if you don't want to, but I'm going to use A, not 2. So f prime of A is the same definition with this, but x is A. Same thing. I just replace x by A. That's one possibility. So h approaches 0 from f of A plus h minus f of A divided by h. Question, do I have to use this? No. Just find this and replace A at the end. Or just replace A in here and just use A. So let's illustrate with one simple example. Simple. Let's say f of x equals 2x squared, and we want to find f prime of 3 with using this definition. Fine. So in order to find f prime of 3, I will write limit as h approaches 0 from f of 3 plus h minus f of 3 divided by h. And just replace, put the function in. So limit as h approaches 0. I see a 2 as a constant. I will put it in front because I want to simplify. It's a constant, it's a factor. So then I have 3 plus h squared minus 3 squared, which is 9 over h. With a 2 in front or 2 in front here. Because remember, a constant times a function. The limit of a constant times a function is the constant times the limit of the function. It's up to you. Okay, so I have to have 0 over 0, right? So there is hope. Of course, this function is differentiable. All I have to do is just calculate this. And I'm done. So 10. So this is limit as h approaches 0. I know what this is. 9 plus 6h plus h squared minus 9 divided by h. These two go away. That's the first step. Second step, h in the denominator has to go away. And I have h, 6 plus h divided by h. These two go away. I apply the limit, and I get 12. So this is the slope of the tangent line at x equals 3. If I'm asked, for example, now to find the equation of the tangent line, find the equation of tangent line at 3, 9 times 2, 18. Then I know y minus y1 equals the slope times x minus x1. And this is 12x minus 36 plus 18. So this is the equation, 12x minus 18. What does this represent? It's the equation of the tangent line at the point 3, 18 to the graph of 2x squared. If we are asked to do that. This was in addition. Added in. And now the other possibility. So this was number 1, and there is number 2. So the other possibility for f prime of a is limit as x approaches a from f of x minus f of a divided by x minus a. You can say, how did you get this? From our best friend, px f of x, and q, which is a f of a. And determining the slope of this secant line. F of x minus f of a over x minus a. When q gets closer and closer to p. And you can say you're just changing the notation? No. So this is another way of finding the derivative function at a value, particular value. Do you have to use this? No. Sometimes this definition is easier though than this one. Do you have to use this or this? No. You can always stick with the only definition that f prime has. F prime of a number has 2 options, this or this. But you can stick with this forever. However, this is not a bad idea to have it in mind because sometimes some functions work better with that.